Oh, hi guys, I'm not here today, obviously. We're going to do a video lesson, so I'm going to fill in the note as normal on video. Sorry about your exams. You'll have to wait until next class to get those back, as I'm away today on a field trip. I've left some paper copies of this note in your classroom, so if you'd like to go grab one, you can. Otherwise, follow along. You can skip parts that are too easy for you if you like. This is almost entirely a review of last year. It's graphing trig functions. The only new thing is that you have to be able to do it in radian mode. Okay, so I've provided a table of values for sine x and cos x so that we can try to plot those values, see what the functions look like. You should be able to fill this in without using a calculator. It's all special triangles and cast and unit circle. So recall your 45, 45, 90 special triangle. Sine 0 is 0. From this triangle, we see that the sine of 45 is 1 over root 2. Sine of 90 is 1. You need to remember that from your unit circle. 135, well, that's just 45 degrees in the second quadrant. Now, in this quadrant, sine is positive, but cosine is negative. 180 degrees, its sine is going to be equal to 0, and its cosine is going to be equal to negative 1. 225, that's 45 degrees in the third quadrant, where sine and cosine are both negative. 270, that is going to have negative 1 for the sine, 0 for cos. This should actually be 315 degrees. That's a typo. This is 45 degrees in the fourth quadrant. So your sine is going to be negative. Your cosine will be positive. At 360 degrees, sine is 0, cos is 1. And I'll fill in those last few coses I didn't do. 1 over root 2, 0. Okay, now we can use this table of value. We can sketch this graph. So let's see. Sine, let's do sine in blue. Sine of 0 is 0. Sine of 90 is 1. Sine of 180. Every 90 degrees, it jumps between middle, max, and min. Sine of 270 is negative 1. 360. We connect the dots, it looks something like this. Now let's do cosine in red. So cosine of 0 is 1. Cosine of 90 is 0. Negative 1. This. I didn't really include the 45 degree points. We have plenty without it. So red is y equals cosine of x. And blue is y equals sine of x. So that's the basic shape of the sine and cosine functions. Now, if we kept going, if we kept adding values, say if we added another 45 degrees here and got, 300. Well, let's add another 90 degrees, actually. We had 450 degrees. Well, that's the same as the sine of 45 degrees. Remember, those are coterminal angles. Sorry, sine of 90 degrees. Those would be coterminal angles. So it would start to repeat. So these functions really, they keep repeating over and over again due to the fact that two coterminal angles have the same sine and cosine. Okay, so what do we notice about these graphs? Well, there's interesting properties. Like we've said, they repeat. Also, they both have a maximum of 1 and a minimum of negative 1. And of course, there are other interesting properties, but we'll just name a couple. Because these functions have so many interesting properties, there's a lot of unique vocabulary that can be used to describe them. You'll notice that there is a horizontal line that goes halfway between the max and the min that really kind of cuts them in half. This function is called the equation. Called the principal axis, or the equation of the principal axis. So no matter what, even if my sine function is shifted up, there's still a horizontal line that goes halfway through it that has this property. Half the difference between the minimum and maximum values, or the distance from the principal axis to either the max or min, that is called the amplitude. The change in independent variable corresponding to one cycle, so how long before it starts repeating, that is called the period of the function. And any function whose graph has a regular repeating pattern is called a periodic function. Now, trig functions are periodic, but you can have a periodic function that's not a trig function. So if I sketched a graph like this, sharp edges, not a trig function, but still periodic. Or maybe I had a function that just goes like this. Something like this, that would be periodic, it repeats. Okay. Now let's look at example 2. Example 2 is very much like the previous examples, except now note that we are in radians. And we're going between what would be negative 180 degrees and 180 degrees. Now these actually aren't too bad to sketch because they look exactly the same. We have sine x is going to look like this up until 180 and negative 180. But we need to know now that this is not 180, this is pi 0. This is not 90, it's pi over 2, 0, 0, negative pi over 2, negative 1, negative pi 0. So this is y equals sine of x, cosine of x, same idea. Its shape is going to look the same, but we are now in radians. Beautiful. Okay, so let's look at the next example. Now, these we can think of as parent functions, and we can apply all the transformations we've already learned to these. So for instance, if we have y equals 3 cosine theta plus 1, well, this 3 is a vertical stretch, 3, and 1 is the vertical translation. Now, that vertical translation will move the principal axis up 1. And let's look at a few points. Let's look at the point on cosine. We have the point 0, 1. Well, that becomes 0, and then we multiply 1 by 3 and add 1. 0, 4. So we have the point 0, 4. Now we haven't changed the x values at all. So every pi over 2, we're actually going to go between the principal axis. The minimum is going to be pi. This is negative 2 because our vertical stretch is 3. That affects our amplitude. Okay, so you may remember this from last year. We go down 3 from the principal axis. And we can check this. We can take the point pi negative 1, and that's going to go to pi negative 2 if we multiply it by 3 and add 1. Okay, and then it's going to repeat in this pattern. So it's going to look something like this. Okay, so I've graphed 2 periods here because we're going from negative 2 pi to 2 pi. Got to be very careful about okay. Okay, so that's that example. Example 4 is done for you on the posted version of the handout with the filled in. So let's look at example 5 because that's very important. So here we have a horizontal stretch of a half. So what that means is, well, the period is actually going to be a half. It's going to look like cosine, but instead of this being pi, this is actually, instead of this being 2 pi, this is just, oops, this is just now pi. And so we can go another pi all the way to 2 pi. And we'll get 2 periods in. These values are still 1. This is pi, this is still pi over 2, and this is 3 pi over 2. So the horizontal stretch of a half means you can get twice as many periods in between 0 and 2 pi. So let's look at this. So in a trig function, A represents the vertical stretch, and also that affects the amplitude. K represents the horizontal stretch, and the period is 360 degrees divided by K, or 2 pi divided by K, if you're in radians. C is the horizontal translation, and D is the vertical translation, and it's the equation of the principal axis, or I should say y equals d is the equation of the principal axis. So once that's done, try example 6, check it off of the posted version of these notes, and then try the homework. And we will review all of this next day.